Live.
Good morning and welcome to the Level Up Hour, where we contemplate containers, consider Kubernetes, opine on OpenShift, and in general help you to understand a little bit more about this world of containers, Kubernetes, and OpenShift, especially if you are somebody coming from that Red Hat Enterprise Linux background as a systems administrator engineer. And so we've got a great show today in which we're going to be talking about GitOps and developing your CI/CD pipeline and some tooling that are available to help that work a little better. So I'm joined today by my colleague Scott McBrien, otherwise known as Stabby. And we have our guests today, Vincent DeMeester and Mayor Friedman, who are going to share some of their knowledge about what all of this is about when you hear these letters CI/CD. I just want to remind everybody, please do like, subscribe, and share to everyone to let people know that we're on air. And let's jump right into this. So we're talking today a little bit about GitOps and CI/CD pipelines. And so, like a lot of acronyms, these get bandied about, and everybody assumes that everybody knows what they are. But Vincent, maybe why don't you share with us what is CI/CD?
So I think the CI part is kind of close. Like everybody understands the CI part. I think for everybody it means continuous integration, and it means although even continuous integration can mean different things for different people, but usually it means I build on each commit or each PR or each whatever, but on each change that me and my team do, I run some set of tests and some set of validation, like, I don't know, linters, anything. So the CI part, I think, is kind of simple to grasp. Yeah, grasp is better. The CD one is like really more difficult because people will put different meanings behind CD. It's going to be continuous deployment. It's going to be what was the other one? Continuous delivery. And if you dig a little bit more into those two, and even more, I don't have any other meaning in my head, but it can depend different things. Like continuous deployment, at least in my head, means anytime there's a change, is deployed somewhere. But continuous delivery doesn't necessarily mean this. I don't know if anybody wants to add to this, but yeah, it's the CD part is more in flux, and I think the CD foundation, so the foundation that kind of try to work around those thing, is working on a paper around this, like trying to define what is CD and what we put behind this.
Well, so let's dig into that a little bit. And so let's first start with the CI part, because I think if you come from a developer background, integration is something that you deal with all the time. If you're somebody coming from more of an infrastructure background, it might not be as self-evident as you think. And so, Mayor, maybe before we dig into the complexities of the CD, because it does potentially mean a couple of different things, explain to us, our audience, again, thinking that about the folks who are coming more from that infrastructure background, what is it you're doing when you're doing integration? Forget it continuous, forget making it continuous. When you do an integration exercise, what is it that the developer is doing?
So I'll try to look at this from the infrastructure perspective. And I have to start with the words continuous integration, unfortunately, because the whole essence of continuous integration is to supply confidence that proposed changes will actually work as intended. And as Vincent said, there are many perspectives to look at CI and where it happens. It can either happen on a pull request, it can happen after the merge. So different schools tell different stories as to what CI is. But essentially, from the infrastructure perspective, I think the easiest thing will be to use an example. Imagine you have a repo that controls your infrastructure, right? As an infrastructure person, I have multiple such repos. And every time I want to make a change to any of my infrastructure, I will submit a PR to that repo, maybe get a peer to review. And essentially, I want to see that the outcome is what I expect it to be, even before I merge. And after I merge is even more important, but harder to predict. So the integration part comes when different team members collaborate on the same code, on the same source code, to produce a single result, which is the artifact. And that is also an overloaded word, but I guess we can pick it up from here.
All right. Well, so I think we have a fairly clear picture there now on this integration piece, which, again, I think is very self-explanatory to almost anybody who is working as a developer. But the exercise might not always be quite as clear. But thank you for that clarity. Now let's get into the more complicated half of this little acronym we're dealing with, and that's CD. Vincent, you talked about how there might be a couple of different ways that D is interpreted. It could be delivery or it could be deployment. Maybe if you could give us a little bit of clarity on the difference between the two of those.
So continuous deployment for me is a way of doing continuous delivery first. It's continuous delivery is I'm able to deploy continuously, and by continuously it means at a given set of at a given period of time or at a given set of events. But I want to be able to deploy continuously something, and continuous deployment is just about the deployment. Like I do something, I deploy the thing that I built. I have confidence that it works because it was tested. I can deploy it already directly, for example, in production. That's usually what people think when they talk about continuous deployment itself. When we talk about continuous delivery, it encompasses a broader scope. It can be the whole process that goes from source code commit to the actual deployment. And in this process, there can be manual approval. There can be the sets of events that's gonna, I don't know, for example, for container image, that's gonna run some security checks on an image and wait for it to get back, etc. So the continuous deployment is just a smaller view of what continuous delivery is. And yeah, I'm trying to think about the other thing.
Well, well, while we contemplate that, I'm actually going to ask Scott. So Scott, coming from an infrastructure background, tell me a little bit about how integration and delivery and deployment have looked to you, because my recollection is you have worked in an environment that aspired to maybe some of these things, but perhaps has not always achieved them. And this is in a former life, right?
Yeah, and I think that even today we meet with a lot of people that are still very monolithic in their code design and deployment. A lot of the production operations folks, like they're used to shifting a large version forward all at once. And with that comes a fair amount of risk, which is why I think it's very challenging to do those migrations and upgrades and deployments. And so this is a change in thinking, and it says, hey, let's take a lot smaller bites of that elephant so that we can have a lot less risk at each incremental change, so that overall we're getting to a better outcome with our software product. And so, by breaking up the changes to be much smaller and more consistent, we're minimizing the amount of risk to our infrastructure for each individual change, rather than being like, okay, we're running this version on this operating system. Cool, let's completely change everything and redeploy it.
Right. Well, so, there has been a big move in the industry towards more of a microservices approach as opposed to a monolithic approach for applications. But it doesn't make much sense if you're going to have a microservices approach to deploy it like it was a monolith, right? And so CICD, in my mind, works very well with this larger picture of really trying to break things up, reduce that risk associated with updates, and also to be able to push those updates without having every single piece considered, reflected, and so on. And it has a lot to do with the app design, but at the end of the day, your strategy for testing, integration, and pushing that thing out has to be consistent with having that actual design, right? All right, so that's that world of CI/CD. And so we've talked a little bit about why would people implement CI/CD, and I guess I would ask again, Vincent and Mayor, is there something that we've missed here that if we're thinking about, you know, an IT organization that might not be doing this yet, what is it that they're going to be what are going to be the big drivers for them that are going to push them to pursuing a more CI/CD approach to deploying applications?
I think Mar said confidence. I think this is the really main benefit, because the more you build, the more you try things, the more you test your changes, the more you will be confident that it's going to work when you actually deploy it. So I would say the main benefit is going to be confidence. So that kind of confidence-driven development. And I would also assume that the more people will go towards CI/CD, the more they will have the will to automate things and simplify their day-to-day work. And thus, I think that would be kind of a side effects benefit, which would be because we do things more often, we see the pain point, we automate the pain points, and we kind of become more efficient day after day.
I think it will also reduce a lot of the day-to-day effort, allowing people at the various companies to focus on what matters and the things that are more interesting. I mean, I can do the same thing over and over again. Eventually, I'll get tired. I want something to someone, or doesn't matter, something to do it for me. And automation comes for the rescue at that point. So it allows people to focus on what's important, and I think more importantly, it allows everyone to find issues more quickly, right? If you only promote once in a long period of time, and you promote a lot of changes, be whatever promote means in this context, you're also potentially promoting a lot of bugs, or maybe just a bug that was introduced in the very first commit of this batch of changes will be very hard to refactor back. Whereas where you deploy single changes and you deploy everything, you discover the bugs immediately, if not even before you deployed anywhere, depending on what kind of continuous you do.
Right. Well, and you know, what you were just saying suggests to me, and this, you know, I think is understood to be an underlying truth too, is that there has to be a bit of a culture change within an organization once you start going down this path. Is that it's not enough to simply say that you have erected the infrastructure and the, you know, the pipelines that everything flows through. There has to be a different way of thinking and acting and working together that complements that, because you do have to change some things because of the very facts, you know, things you were just talking about. And so that kind of really moves me to another question, which is, you know, in your experience, what are some of the recommended practices that people should be thinking about when they are moving to this more CI/CD approach and they are trying to build out a CI/CD approach?
So I think one of the things that are very important happens during incidents. When suddenly something happens in your production environment and you need to find out what's going on immediately. So one of the more important things are traceability. We need the CI/CD pipeline to be able to implement traceability in such a way that no matter where in either the supply chain or in the environments you look, you can see exactly where everything came from. What pipeline deployed those changes? Where was that pipeline created? What triggered the pipeline? What are the code changes that were introduced, or what is the process that caused the current environment to look like it does? So traceability is super important. I also think that to a certain degree, what's important in these processes, and something that's important to design upfront is reproducibility. We want the pipelines to generate the same results every time they run, regardless of when they run. And with that also come thoughts about when am I going to do each action in my pipeline, and am I okay for choosing to do several actions more than once? One example would be if you're deploying onto OpenShift and you use container images and you deploy something, promote something to production, it's important that the promotion notion stays with you, as in I am promoting a certain version of my code base, of my binaries, artifacts, deployment manifests, whatever it is. I'm promoting something that was already built and tested in stage. So I've seen multiple examples of pipelines that build the container image more than once, for example, once for the deployment in stage, one for production. So I try to avoid these things already in the design phases of the pipeline. And practically one of the important things to consider is how the pipelines match the current working practices of the organization. One example will be the branching strategy. The CICD pipelines need to match the branching strategy for them to actually deliver what they need to deliver, which is a seamless experience for a developer from merging their code to that code being in production. So it has to match the current working processes that are already established. And obviously more technical things like the structure of the different repositories and whether there are differences and what will they be, and how do you generalize everything into a single concept and then implement the differences.
Well, first of all, I love the idea of a promotion notion. I'm going to use that from now on. So you really covered a lot of interesting ground there in terms of how you have to think through the specifics of an organization and how they work. Is that there isn't a one size fits all necessarily, that you just drop this infrastructure in and it's going to work for everybody. And so, one of the things that caught my ear in particular was talking about your branching strategy and how that has to actually be congruent with the way you set up your pipelines. And so, Vincent, maybe could you talk a little bit about the relationship of sort of branching strategy and the pitfalls that might arise if you don't have a good fit between that approach to branching versus the way you set up your pipelines?
So I'm not sure exactly what Mauro was referring to for the branching strategy.
Okay. Well, tell me what some other pitfalls, and then I'll put him back on the. I'll put him on the edge on that.
I think for me I'm very biased on this topic sometimes. For me, one very important pitfalls that happen a lot is tying yourself, whatever runs into your CICD, to a specific or CICD orchestrator, like, I don't know, Jenkins or Travis or whatever. And this used to be something you didn't really have a choice in the past, but now with the rise of container images, etc., if you design your steps in your pipeline correctly, each and every actual unit of work doesn't even need to know that it's part of the pipeline. You just need to have a set of inputs, a set of outputs, and then you can use this elsewhere. I don't know, today you're using Tecton for your CICD, tomorrow it's going to be something else. If you design it well, you just kind of have to move to a new language of description, but the actual core value of what your CICD does is there. And usually this is one of the pitfalls. You tend to tie yourself a lot to whatever the tool you're using. And then when this tool is not maintained anymore, or when it's like a performance pit or anything, then you're kind of stuck to reinvent a lot of the wheels when you switch. And now that we have container images, And that's where I'm very based, because I used to work for Docker before, etc. So I'm like, I'm in container image for a long time, and I'm yeah. And yeah, it's okay. Yeah, people can work for Docker and then Red Hat.
Of course. Of course. So on that note, Mayor, I do want to return back to that question on the branching. Again, I want to sort of explore some of the pitfalls that that an organization might bump into when they are doing CI/CD. You called that out, and I can kind of imagine that, but give us a little bit more color around what happens if, for example, your branching strategy is not consistent between your pipeline and how you actually do branching in your code base.
So I think that Vincent actually answered that question, maybe without even understanding it. The pitfall that he mentioned was not tying your CI/CD system into the orchestrator or build tool like Jenkins or whatever else you're using. Now, we've all done it in the past. You only learn what not to do by actually doing it in the past. I even have blog posts saying you should tie it to the build system. It's amazing. But I think the only thing that's common underneath is really Git, the source code itself, which is usually Git. Let's stick to the Git example. And when you stick to Git to either tag your artifacts or define what you want to deploy and promote and when, you're actually loosening yourself, decoupling yourself from the build system by using the Git commits. So for example, a relation between a CICD between CICD pipelines and branching strategy may be whenever someone merges something to the development branch, right? Assume an organization is working with Git flow. Whenever someone merges to the develop branch, we want an image built and deployed to the dev environment. And then you have the main branch, and whenever someone merges or something gets merged into the main branch, we want the image, the artifacts built again, and then we want to deploy to stage. So that is already a connection to a possible very minimal merging strategy with a develop branch and a main branch. And that may also connect to the previous points about continuous deployment or delivery, which is indeed the difference in the process. And if there is a button involved there in the middle or not, or at least that's what the legend says. And when you want to, so everything from the main branch, at least in our branching strategy, goes directly to the stage environment after it's been tested in a dev environment prior. And when we want to promote something to production, we again go to a branching strategy, which is don't do anything, just choose a commit SHA that worked in stage and promote that. So we're very GitOpsy in that way. And we are decoupled from the build system, which is the pitfall. And we also did a sort of a connection between a Git branch and an environment. So you get a direct link and you know if something is wrong in production, look at what commit SHA is broken. Something broken in stage, look at master, at the main branch, and so on.
All right. Yeah. So Scott, anything you want to add on to any of this? Because I think this is a natural transition for us to maybe start talking about what are some of these tools that people use, because I think there are things that we offer and that can help with this. But before I turn to that, is there anything from your experience or from what you hear from customers that seem to be some of the pitfalls that they're bumping into?
I was just really excited. I mentioned this in chat to hear Mayor talk about promoting artifacts throughout the pipeline instead of rebuilding at each stage. Because, there's been more than once where maybe even at the Crimson Haberdashery, where production systems in no way match dev or stage. You don't find out until you actually deploy it, and then it's like, oh no. So yep. that was excellent.
All right. Well, so let me come back to this question then. On the tooling, and Vincent, you raised some interesting questions and points about sort of where the build system fits in, but let's look at this from a broader perspective in terms of what is the tooling that people are using to be able to build effective CI/CD pipelines. What is it that we're recommending and thinking that are tools that can lead to success in a variety of organizations?
So I think the tool that everybody knows is, and where everybody has a kind of a love-hate relationship with, is Jenkins. It has been around for, I don't know, probably 20 years or so. And this is like, this is up until even now, there is new alternative, and we are developing new alternative, but up until now, I think this is still the main tool that everybody knows. It comes with a lot of pitfalls because it started 20 years ago. So containers, it doesn't know, Cube, it doesn't know. There's a lot of things it doesn't know, and it has been architecture with this plugin mechanism, with this, which is super nice, super awesome. But when you have 1 billion plugins and how you manage updates, etc., it's like it comes with a lot of problems. And on the OpenShift side, we did ship with a Jenkins instance in OpenShift 3. We still do in OpenShift 4, but those are kind of really hard to maintain and administer, mainly because depending on what you use of your cluster and what teams are there, you might need or want a different Jenkins instance for each team, because each team has different needs. Each team might want to build and need this plugin, the other plugin, but different version, etc. So it becomes like a huge, hard thing to maintain. And this is where new alternatives come from. And that are built like that are cloud native, and one is OpenShift Pipeline, which is the one I work on.
Oh, what a coincidence! So Scott, let me divert a bit from that. So certainly Jenkins, it's been around for a long time, and I think Vincent makes a great point that it precedes in many ways some things that are really sort of central to the world of CI/CD at this point. But you know, you get feedback from our RHEL customer base. Is there any other tooling that's in this picture that they're maybe trying to cobble together what they want to do and that they're maybe struggling with?
I mean, I think that Jenkins is kind of the widely used tool for a lot of stuff, but because it's used for a lot of things, as Vincent pointed out, it gets really gnarly, because to do everything well, you can do, or to do everything, you could do no single thing really well. And there's been a bunch of other kind of SaaS offerings that people can use, and but yeah, I think Jenkins is kind of the beast everyone knows.
Right. Well, so that brings us to what is OpenShift bringing to this endeavor, right? What is it that OpenShift does and allows an organization to do when they have this objective of building CI/CD pipelines that achieve those objectives we talked about earlier, and that in some way can align to their particular approach to building code and to their application lifecycle. So Mayor, tell me a little bit about what OpenShift brings to this picture that maybe has been missing or that is especially effective.
Right. So first of all, I'd like to point out that I openly and publicly like Jenkins. I think it's a very good tool. It does what it's supposed to do, which is to run things. You just need to tell it how. And telling it how is the difficult part, because managing Jenkins, whether it is the Jenkins instance itself, whether it is the underlying infrastructure for the nodes, for the main node, the master node, whether it is the jobs on top of that, which is probably the most difficult part, because even when you think of scale, it gets even worse, because then you end up with a Jenkins instance with 800 job definitions on it, all composed differently. We use Jenkins Job Builder, so it's easier for us to compose different jobs of different types and to even allow our users to take advantage of that. But eventually, I think the common characteristic and what we've been going for, or what Vincent's team have been going for, and we received as customers, is the concept of building small boxes and stacking them together in every way that we want. So OpenShift pipelines, they come in a very it's a very generic tool. Every pipeline that you can imagine eventually is a pipeline, and a pipeline is divided into tasks, and each task may have one step or more, and that's the concept. And when you are able to build different pipelines but have the steps reusable, it brings a huge advantage. And it's not even with Jenkins specifically, you would need to actually define each and every job and find your way to reuse components with YAML magic and things of that sort, which is never fun. We ended up one time with a 5,000 line file of Jenkins job builder definitions for a single project, for a single product that we are running, and our team currently runs over 50. So imagine what would have happened if we kept going that route. But I think what OpenShift brings to the table is the elasticity. That's the most important feature that it brings, and that is the reason we migrated all our CD processes from Jenkins to OpenShift pipelines, because of the elasticity. No matter how many, we used to fight with Jenkins. We used to tell tenants not to promote too frequently, not really in those words, right? We told them, never mind. We were encountering overload constantly with too many deployments happening at the same time. And with OpenShift, it just doesn't happen because the cluster can be defined with auto-scaling, and you deploy as many resources as you want. Also need to clean up because these are custom resources and etc. So cleanup is important. But essentially, you define things once, you can reuse them from different places, and you just build your pipelines any way you need. And whenever someone wants to run them, they just go into the namespace and hit run, because it's embedded in the console, which is super nice. So everything into a single place, which is also the place running your services. That's double nice.
All right. Well, that does sound like. Go ahead.
Yeah, I was going to say, I think just to add to that, one of the goals of OpenShift Pipeline, which is based on the upstream project Tecton, was to also kind of speak the same language or be more close to what you use to deploy. Because in the end, Red Hat OpenShift Pipeline or Tecton is just an extension on top of Cube. We are using CRDs, etc. So you're going to be able to use every single tool that you use to manage your clusters, etc. You can use them also with Tecton, and that's kind of was one of the goal. And yeah, as Mar said, like one of the other goal was composability and reusability, be able to easily define tasks with multiple steps, but things that are reusable, so that you define them once, you can even share them somewhere. And we do have a community sharing place somewhere for common used task, and from there you just like get your pipeline and you orchestrate the unit task that you wanted.
I think you hit the goal on spot with customers reusing the same systems they already use to deploy their services. We did exactly the same thing. Our team, which is a customer of OpenShift pipelines, we have this repo that we use to define and deploy all the services that we run into different OpenShift clusters, and OpenShift pipelines just came naturally into that picture. We reuse the same system, of course, and it was one of the best migrations that we did from Jenkins to OpenShift within the same system. It was spot on with the goal, and it hit right there.
All right. Well, so it sounds like this is actually a path to being able to do things, for lack of a better word, much more easily, with fewer pitfalls, less complexity, and of course, complexity brings in the possibility of things going wrong. I'm particularly intrigued by the idea of being able to share out particular, ways of doing the, sort of the composition and other sorts of things, because that also starts to build kind of a community of practice in which there is a way that you do things. It's not that that's the only way, but there is a common way that can be shared, and it becomes, in a sense, tribal knowledge, right? So talking about the tribe a little bit, can we talk a little bit about the roles of the different people who are involved in building these pipelines? Okay, so first of all, let's talk about the ops role in sort of building out CI/CD pipelines. And who wants to take that one? There you go.
I am the
I
ops person.
I was gonna put Scott on that one, but you know what? No, I want to hear from you, Or.
Right. So I think first of all, the definition of roles may be different in every organization, and eventually we need to formulate the relationship between the different roles in an organization in order to decide who does what. A sort of I'll use a word my team uses a lot, a contract between each layer of people supplying anything. So in our team, for example, we are responsible for the CD process as a whole. The services that we run, the development teams, they come with their source code, and we have a sort of a contract that they put their deployables in their code repo, and we are responsible for the pipelines themselves, and they are receiving that as a service. So in this example, the ops team is responsible for not only supplying the pipelines, but also for building, designing, maintaining them, while the developers in this equation are responsible, in our case at least, to define their pipelines in a declarative way. We have this system I started talking about. I'll say its name: App Interface, Contract Reconcile. Go look at our GitHub organization. It's awesome. So this system allows the teams that we service to define in a declarative way what they want deployed where, according to the branching strategies we mentioned earlier. So they're going to say something like, this is my repo, and in this path you'll find my deployable. I want it, whenever there is a merge to main, I want it deployed to stage, and in this commit, I want it deployed to production, and that will be their role. Behind the scenes, automatically, our systems, or be it people, depending on the level of automation each organization is at, will provision these pipelines. And based on the same declarative manifest, will also be automatically triggering pipelines based on different conditions. For example, if the main branch is pointed at stage environment and a commit changes behind the main branch, we'd want it redeployed. So the ops team in this case will also be responsible for making sure that the artifacts are being delivered into environments according to the contract, once again. So the collaboration in this is essentially through a contract. We decide upfront who does what, who's responsible for what, and who stores artifacts. And based on that, we define everything else.
I like the term contract because a contract implies a negotiation, right? And there has to be some degree of negotiation between the ops side. No negotiation.
No negotiation.
No negotiation. The contract is well, there's no negotiation after the contract, but there has to be some degree of agreement about what that contract looks like, right? So Vincent, give me a little bit from the developer perspective on this, and how the developer role participates in this and thinks about what the CI/CD pipeline looks like and how it works.
Well, as Mar said, like in depending on the org, the roles are different. But I would think, like, for me, the role of developer here are to tailor, like if we talk about in specific Tecton pipelines, like Red Hat OpenShift pipelines and the notion of tasks, I think developers' role is to tailor the tasks that they might use, the one that are important for them, like building the code, testing the code, etc., to their needs, with, of course, discussion, negotiation, contract with the operational role. But like it becomes, your pipeline becomes a set of elements that are either dev responsibility or ops responsibility. The pipeline itself might be on the ops responsibility, but usually you have you will have your set of tasks to maintain, because this is kind of closer to what you're doing. And yeah, I mean, it really depends on it's also like, we're talking about, for example, OpenShift pipeline specifically, but you can have higher level contracts which would abstract this contract, and I know there's work towards those kind of higher level constructs upstream, for example, where we're trying to think about more like the dev wants to provide this and this set of tasks that are used for them to build, like, I don't know, a Go build and a Go test task. And on the opposite side, we want to be able to easily say, inject these tasks into the pipeline, and the pipeline will also build an image from this. We'll also inject some other steps that tasks that are coming from someone else, the operation, for example, to secure or scan the image. So yeah, I think I'm answering a bit all over the place, but yeah.
Well, I know I followed along, and I think this is what one of the things that comes across here is that it has to be a very collaborative process in which it's not something that can simply be installed and now you have this thing that does the thing. There's a long series of, again, negotiations, I think, discussion about, well, okay, so here is how we do things now. And the thing about it is that how we do things now is not always the thing that you want to continue. I mean, sometimes you are undertaking this for the very reason that you do not want to do things the way you do them now. You want to move to a new and better way. But at the same time, it's not like you want to give up the way you do everything. And so that's from a developer's perspective, or from the ops perspective, it's let's take the things that work for us, but then maybe move in some new directions with CICD, but also anticipate how do we really actually push our apps out, as opposed to what we had imagined. We're an organization that might not imagine itself as being an Amazon, or a Netflix or whomever that, is pushing out 10,000 code changes a day. That implies a somewhat different CI/CD pipeline. It implies a different relationship between the developers and the ops and many other things, right? So let me ask, if we just get a little more specific here, what are the administrative tasks? What is day two for setting up your OpenShift pipelines? What does that look like for an organization typically? Understanding that it's going to vary from org to org. Maur, you have some thoughts?
To that?
Yeah, well, sometimes I just want people to jump on in. Scott, you feel free to clarify.
My OpenShift knowledge is known to be vast and deep in all things.
All right, so I'll try to tell a bit from our experience what we had to do. So I think some of the day two operations, as always, day one is usually the get started and get things working, and day two is usually the improve part or iterate part. The day one operations on OpenShift, for example, day one provision a cluster, day two upgrade the cluster. So I think the day two operations will be partially to modify and improve the pipelines as new needs arise and as bugs are discovered, and there are bugs everywhere, including in your pipelines and in ours, and we haven't found all of them, and we never will. But the day two operations are more in the direction of maintaining, and I think for maintaining and keeping day two operations, even different ones, to keep them sane and to keep them sustainable. So it will be very important to focus on the day one operations, how you set up those pipelines, how you really collaborate between teams just by storing the right resources in the right repository. by reusing actual resources between different namespaces according to your deployment systems and how you manage your code. Manifests are code as well. So how you deploy the same manifest into different namespaces, if you're servicing more than a single team, you'd probably want to do some compartmenting, and create separate namespaces for pipelines. So you'd need to be able to keep maintaining those pipelines, and you'll need to be able to scale. Everyone needs to think of scaling in any sort of magnitude. So how are you going to onboard new teams into your process that you've created in your day one operations? How are you going to handle an issue with your pipelines by making a single change and having it applied to all your different environments and to all the different pipelines that are reusing this small package? So I think a lot of the day two operations actually depend on how you plan to deploy your resources. And that's a perspective of how you deploy your services. So OpenShift Pipelines really just doesn't bring anything new into this concept. Every organization was already thinking of these things. How do I deploy and how do I fix my code faster? And those pipelines, they are just code. And I think this is one of the most important things. Yeah.
All right. Well, yeah. So ordinarily we hear a lot of talk about day two and so on, but I think maybe the moral of the story that I'm getting from you today is that you need to get your day one right, because that's where you actually set up the things that you're hoping will provide all these benefits down the road.
As far as you can predict, right? Because it's easy to say, let's plan and let's plan thoroughly and let's not be surprised. But honestly, what you don't know, what you don't know. And when you find out that it's different from what you thought you'd know, it's already too late. And I think that in that essence, it's important to try to plan as much as you can, but also be aware of the fact that there may be changes along the way, and iterations are good. We always say that iterations are good. Don't deliver everything at once. Deliver in pieces that already return some of your investment. And
right.
Yeah.
Well, so that's the thing that was kind of striking me as a bit of a paradox there, is that on the one hand, what we are trying to do with CICD and so much of the, how things are being approached in this space now is really around trying to be very agile. But at the same time, if you're trying to get all of this right at the same time, that's starting to not sound so agile. And so that, in my mind, raises this paradoxical question: is how do you evolve your CI/CD pipelines over time? Because you want to make those good decisions up front. Maybe you don't make every decision at the outset, but you're trying to set things up in a way that works organizationally, works for the kinds of applications you have, and so on. But inevitably, you are going to have to evolve these. What does that look like?
I think Mark said something very interesting on the fact that how when you have multiple teams or even multiple users on your cluster that are doing pipelines and sharing things, how you keep them up to date with whatever change you provide to the pipeline or to the tasks themselves. And this is where I think when you set up, this is kind of for me the day two work of day one would be I discover the thing. Oh, this is nice. This is using cube semantics, etc. I can create something and it's going to be available, etc. But then the day two will be how I keep this available for everybody. Where is my source of truth? And from there, what should I use to update my pipeline? And it's kind of easy there. It's like, how do I build containers? By building containers in containers. This is a bit similar. Like, you can definitely have pipelines that manage actually the delivery of your pipelines in your clusters, and you have the full loop done. This is kind of what we're trying to do, for example, upstream, where we build OpenShift Tecton pipeline with Tecton pipeline. We're doing the same downstream, building OpenShift pipeline with OpenShift pipeline, and trying to maintain in our dogfooding cluster our own all of our pipeline tasks, reusable tasks, etc., they're all defined somewhere in the source of truth, which is one of the Git reports here. And we do have pipeline itself updating itself, validating itself, and keeping any sort of usage of this in the cluster. But this is kind of, there's going to be as much approaches as there is teams almost. Like I'm sure upstream what we do is different from what our team does, and is going to be different from elsewhere. There's going to be emerging patterns there, but yeah.
Well, actually, emerging patterns gets me into one of sort of the last questions in my mind, and that is where is the technology in support of CI/CD going? In sort of that next step, the next phase. What are some of the things that you see happening in this space, and that might be changing, let's say, over the next year or so?
Well, so I think everything is happening on containers. Everything, like every single CI/CD system right now has containers as its core, or some sort of view of containers. GitHub Action is like, you can see them as containers because they are using the actual distribution format, even though they're running VM behind the scene. But so I think, at least I'm going to speak as the lead of Tecton, is I wish something like Tecton would become kind of a standard of reusability. And by standard, I really mean the actual smallest unit in Tecton, which is the task. Because I mean, there's going to be lots of different ways to do things, but when you do want to do a Go build, it's going to always be the same. So if you have the image and a set of parameters that you can give, then your actual tasks never going to change. If you're Red Hat, if you're Amazon, if you're a small company, it's always going to be the same. So I would hope that some of this would kind of become a standard, and then any abstraction that builds on top would kind of speak the Tecton language, so that then you can switch from an abstraction to another, or at least you don't need to buy into something specific to like, if I don't know, if GitHub Action and GitLab builds, I don't know the name, and pipeline as code from OpenShift or something else, is if they are all talking Tecton, then it's kind of a win, because you don't need to only use GitHub Action on GitHub or GitLab on GitLab, etc. You just need to, you can choose whatever fits your team or what you think is the important part for your team, and then you rely on whatever is able to provide you the understanding. Like the same as what happens with container images, but one layer on top on CICD.
Tecton models.
Okay. Yeah. So, Mayor, any last thoughts on sort of that question of where the future is headed?
It depends on who you ask. If you ask the ops team,
well, I'm asking you.
Yeah, of course. But this is a two-perspective conversation. If you ask ops people, it goes into being more abstract, really. And if you ask dev people, it's going away. They don't want to be aware of CI/CD. They want things to work. Like, we don't want clusters. We want abstract concept, and we want our service running. It doesn't matter what's underneath. So I think I agree with Vincent. Everything is going towards abstractions, and the less you know, the less you know. And it still works. And as long as everything works, the less you know is better.
I mean, being from an ops background, I also want things to just work.
All right. Well, thank you, gentlemen, for joining us today. This has been incredibly informative about the world of CI/CD. Those four letters get used so much, and yet I think that sometimes there's not a lot of clarity about what's under the hood and what this really involves and entails. So anyway, thank you again. it is that time for us to talk about sweet internet points. And again, here's where we're at in the leaderboard. Narendev is narrowly ahead. And so we will check back in when we have our next show, and we'll see how that looks. But again, please please share, please tell friends about it. When you join, please ask us questions. Let us know if there's anything that you would like for us to cover in future sessions. So again, thank you for attending.
Thank you.
Thanks a lot.
Everybody.